Ranger 7 was supposed to die, but the problem was whether it could speak clearly before it did. On July 31, 1964, the small spacecraft rushed toward the moon while engineers at the Jet Propulsion Laboratory waited for evidence, not promises. If the cameras failed, the United States would have another public lunar embarrassment. If the pictures came through, the moon would stop being only a bright symbol and become a close, measured surface. The context was pressure. NASA was young, President Kennedy's lunar deadline was still hanging over every budget argument, and the Ranger program had already produced a record of disappointment. Earlier Rangers had been lost to launch failures, spacecraft malfunctions, guidance problems, and camera systems that never delivered what newspapers had been told to expect. That history caused a hard question inside the program. Could JPL build a machine reliable enough to guide itself across lunar distance and return useful data in the final seconds? Ranger 7 became the test of that question. The spacecraft launched from Cape Kennedy on July 28 on an Atlas Agena rocket. First came a parking orbit around Earth. Then the Agena upper stage pushed Ranger outward onto a path that would end at the moon. Controllers checked telemetry, watched power levels, and planned a mid-course correction because a small error early in the flight could become hundreds of kilometers at impact. The machine was not a soft lander. It had no legs for survival and no braking engine for a gentle touchdown. Its purpose was harsher and simpler. Aim at Mare Nubium, warm the television system, and send pictures until impact cut the radio signal. That design sounds wasteful until the evidence is compared with what planners had before. Telescopes on Earth could show the moon's larger markings, but Earth's atmosphere blurred the fine surface. Apollo and Surveyor planners needed more than romance. They needed to know whether slopes, craters, blocks, dust, and roughness would threaten future landers. Ranger 7 carried 6 television cameras, arranged to return overlapping views at different resolutions. About 18 minutes before impact, the camera system began its decisive run. The first frame came back from more than 2,000 kilometers up. Then the moon grew larger, and each picture sharpened the argument. Here the story reversed. A crash, normally the sign of failure, became the instrument of success. The closer Ranger 7 came to destruction, the more valuable the images became. Craters inside craters appeared. Bright rims, dark mare patches, and rough-looking textures replaced the older impression of a smooth silver disk. Landmarks such as Alphonsus helped scientists orient the sequence, while the intended impact region in the sea of clouds gave the pictures a practical target. Engineers studied the signal as a record of whether antennas, timing, transmitters, and spacecraft stability held together under stress. Scientists studied the same frames as a source for lunar geology. For about 17 minutes the chain held. Picture followed picture at a pace that made the lunar surface feel less remote with each transmission. The final useful frame arrived less than a second before impact, then the signal stopped. In many missions, silence means mystery or loss. For Ranger 7, silence meant that the planned ending had arrived after the data. The spacecraft had struck the moon, and the evidence had reached Earth first. The aftermath changed more than one press conference. Ranger 7 restored confidence after the earlier Ranger failures and showed that JPL's operations, tracking, guidance, and camera systems could work at lunar distance. Ranger 8 and Ranger 9 soon repeated the success. Surveyor would try the next step, soft landing on the surface. Lunar Orbiter would map wider candidate sites from above. Apollo planners would use this growing robotic record to think about where astronauts could descend, walk, collect samples, and leave again. No single Ranger photograph chose Apollo's landing sites by itself, and historians should not turn the mission into a simple inevitability story, but the surviving record shows why it mattered. The moon race depended on proof before footprints. That is why July 31, 1964 deserves attention. Ranger 7 did not plant a flag, carry people, or return home. It turned a doomed trajectory into a stream of source evidence. It showed that a spacecraft could be guided to the moon, that television pictures could survive the critical minutes, and that close views could change planning from imagination to procedure. Before astronauts could stand on the lunar surface, engineers and scientists needed the moon to become knowable. Ranger 7 made it clear.